Imagine waking up to a world that suddenly feels wrong. You open your eyes, expecting sunlight streaming through your window, but instead you are greeted by an eerie, endless darkness. You rush outside and find the world cloaked in pitch black. The birds are silent, the familiar warmth is gone. Where the sun should be, there is only emptiness, a black hole of nothingness. At first people panic and assume an eclipse or a technological failure that has tampered with daylight. But then, as hours pass, panic spreads. The sun has vanished. The star that has burned for 4.6 billion years is gone, providing heat and light necessary for life, holding planets in orbit with its massive gravity. This is not just curiosity, it's a window into how much we owe our star. Let us embark on this unsettling thought experiment and discover exactly what would happen. We begin by understanding what the sun really is. The sun is not simply a light in the sky, it's a massive nuclear furnace, a sphere of plasma more than 109 times Earth's diameter. It holds 99.8% of the solar system's mass. At its core, temperatures reach 27 million degrees Fahrenheit. Nuclear fusion fuses hydrogen into helium. That releases 386 billion megawatts every second. That energy radiates outward as electromagnetic radiation. We experience it as heat and light. Its immense gravity holds planets in orbit. Remove it, and Earth loses its anchor. Without the sun, Earth does not simply lose light, it loses its anchor. The sun is both our life source and our gravitational master. The cosmos around us would disintegrate into chaos. To see how, we start with light and gravity, and the speed that binds them. What happens after the sun disappears plays out in precise stages. Light travels at 186,282 miles per second. It takes just over 8 minutes from sun to Earth. So if the sun vanished, we wouldn't notice immediately. For 8 minutes and 20 seconds everything would seem normal. Then abruptly, the last rays arrive and the sun blinks out. Day becomes night in a fraction of a second, not a sunset, but a switch. General relativity says gravity changes propagate at light speed. Gravity goes with the light. At the same instant, Earth stops feeling the sun's pull and moves tangent to its orbit. All planets, moons, asteroids do the same. The solar system disperses. For humans, the moment is both utterly ordinary and unimaginably final. The sky fills with stars as if night had come at midday. Next, we watch the planet respond hour by hour, day by day. The first 24 hours would be chaotic. Cities lit by artificial lights, rural areas plunged into absolute darkness. The moon, which reflects sunlight, would vanish. Stars and distant galaxies would dominate. Temperatures begin to fall, but atmosphere and oceans act as heat reservoirs, slowing the freeze. Photosynthesis halts immediately. Plants, algae, phytoplankton stop producing food. The base of the global food chain is severed in an instant. Within a week, the consequences become obvious. The average surface temperature would fall below freezing, turning once temperate regions into frostbitten wastelands. Oceans start forming ice sheets, spreading from poles toward equator. Millions migrate toward equatorial regions. Governments strain to maintain order. By 1 month, the average global temperature may reach -40 degrees Fahrenheit. Rivers and lakes freeze solid. The oceans remain liquid below but become capped by thick ice. Eventually, even parts of the atmosphere could freeze, nitrogen and oxygen turning crystalline. Humanity's last hope would be underground shelters powered by nuclear or geothermal energy. Advanced greenhouses with artificial lighting could extend survival, but scaling is a huge challenge. Food scarcity would be immediate and catastrophic. After a year, average temperatures could fall to around -100 degrees Fahrenheit, -73 degrees Celsius. The atmosphere would condense and freeze almost entirely, leaving the surface airless and deadly. Cities become buried, forests become brittle statues. Life persists only near hydrothermal vents surviving on chemical energy. In this frozen silence, Earth's final sparks of life return to ancient roots. It is a sobering reminder of how fragile our biosphere is. Next, we ask, could humanity adapt and survive? In theory, yes. Humanity could survive in radically adapted enclaves. Nuclear fission or geothermal energy could power heat and lights for communities. Geothermal hotspots like Iceland or Yellowstone would be strategic survival locations. Advanced greenhouses could grow food under artificial lights, but energy demand would skyrocket. Fusion power, if achieved, would mimic the sun and vastly improve survival odds. Without vast energy, keeping habitats alive and food production running is impossible. Societal collapse, mass migration, and scarcity would create ethical dilemmas and conflict. Millions would die from exposure, starvation, and breakdown of services. A tiny remnant of humanity might cling on, preserved by technology and cooperation. Space stations or Mars colonies would struggle too. They rely on sunlight as well. Long-term survival requires self-sustaining ecosystems, biodomes, closed-loop agriculture. We'd need technologies we haven't yet mastered: fusion, closed-cycle life support, and social systems to manage resources. Survival would be a desperate, uncertain struggle, a testament to human ingenuity and fragility. Most would perish, but a few enclaves might survive for generations underground. Mercury, Venus, Mars, and the gas giants would drift into interstellar space. Jupiter and Saturn would carry their moons with them. Europa, Titan, Enceladus becoming cold wanderers. Asteroid belts and comets would scatter. The solar system dissolves. Earth becomes a rogue planet, a lonely traveler through interstellar space. Astronomers have discovered rogue planets wandering between stars. Earth would join them. Capture by another star is possible but rare. It would take billions of years. This grim scenario won't happen tomorrow. The sun is stable for about 5 billion years. Yet imagining its absence shows how dependent we are, and why we must plan for the very long term. Preparing means mastering space travel, closed ecosystems, and reaching other stars. Within 8 minutes, daylight vanishes. Within days, the planet cools. Months and a year bring collapse and a frozen world. Humanity might cling on underground, but civilization as we know it would end. Thank you for joining me on this journey. If this fascinated you, subscribe to beyondx and ring the bell. Treasure the sun, because without it, there is no us. See you next time on beyondx.